the NMOS transistor can be replaced by a short circuit whenever the input is 1. Because of this short, the output will be pulled down to 0. The output will be pulled down to 0. It will be pulled down to the ground. The ground means 0 only, right? So the output will be 0 whenever you apply 1 to the NMOS. Okay, right. What will happen if you apply 0? So if you apply 0 to the NMOS, the NMOS will not be active, right? So there is an open circuit. When you apply 0, the NMOS will be off. So there is an open circuit here. So your output, there is only one way, it should be connected to VDD. All these are static circuit, guys. What do I mean by static circuit? At any point of time, the output should be connected either to VDD or ground, which means that at any point of time, the output should either be pulled up or pulled down, right? It cannot exist without connecting to any one of these two. That is what we mean by static circuit. At any point of time, you will get either logic 1 or logic 0. Logic 1 means it is pulled up and logic 0 means it is pulled down. This is the output waveform that you will get at any point of time, right? So here, when the NMOS is off, means the output is through the resistor, it is connected to the VDD line, that is the 5 volt line. So the output is at logic 1 because it is pulled up. So when you apply 0, the output will be at 1 because the NMOS will be off. Pulled up output you will get. This is how the inversion happens here. That's it. Simple. Okay. So this is the working of a resistive load inverter, which I think you would have understood, right? Thanks a lot.